Hi everyone, so in today's class we will be learning about abstract classes and interfaces in Java. This is the part 5 for object-oriented programming. So let's begin. So first question is, what are abstract class, right? So let's understand with a realistic example. At the moment, just focus on this thing. Say, let me open a new page rather. Yep, yep. Say that this is a vehicle. This is a vehicle. Now what is a vehicle? Anything that moves, right? I mean, um, any automobile, but this can be anything. A vehicle can be a car, a vehicle can be a boat, a vehicle can be a train, or even a motorcycle, right? Motorcycle, or aeroplane. All of them are vehicles, right? All of them are vehicles. So if I ask you, can you create a car? You would say, yes, I can create a car. Can you create a boat? Yes, you can create a boat. Can you create a train? Yes. Motorcycle? Yes, you can create a motorcycle. Aeroplane? You can create an aeroplane. But if I say, can you create a vehicle? No, you can't. Why? Because vehicle is just a, now look at my words, concept or idea. Vehicle is just an abstract idea, right? It's just an idea. You cannot create a vehicle. You can create a car, boat, train, motorcycle, or aeroplane. All of these are vehicle. Yes, they are vehicle. But can you create vehicle itself? You can't. Why? Because vehicle is just a concept. Vehicle is just an idea, right? So that is the thing. Anything that is just a concept or just an idea, and you're creating a class like that, this is called an abstract class. Abstract class. Now, what I mean by this? Say, for example, vehicle gives the idea to car, boat, train, motorcycle, and aeroplane classes. For example, what are the things that a vehicle should do? A vehicle should be able to horn. It should play a horn. A vehicle should have an engine sound. Engine sound. Right? Let's say only this two. A vehicle should have a horn and an engine sound. Vehicle class only says that like it can play a horn, it can have an engine sound, but it doesn't say the implementation, meaning these methods in the vehicle class are empty. Okay, because a car's horn a car's horn would be, um maybe I have written the example. Yeah, a car's horn would be beep 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 beep, right? A boat's horn would be what? A boat's horn would be, again I have written this, beep beep. A train's horn would be honk, something like this. A motorcycle would be, I mean, just think about it. Airplane, airplane does have horn, right? It does, yeah. Emergency horn. Zoo, 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 something like this. So everything has a horn. Yes, you are right. Vehicle says that every vehicle should have a horn, and they do, but they sound all different. Car sounds like this, boat sounds like this, train sounds like this, airplane sounds like this, and motorcycle maybe something. It sounds like something, right? Okay. So that is the thing. Abstract class gives you the idea that a vehicle should have a horn, but it doesn't tell you how it should sound. That's the purpose of the child classes: the boat, the car, the train, motorcycle. Vehicle class doesn't tell you how the horn would sound. That's the purpose of car, boat, train, motorcycle, and airplane. Vehicle just says, hey, you gotta have a horn. That's it. How? That's not its concern. Let's come to the second part. Vehicle also says that, um, every vehicle should have an engine sound. Say car has maybe what was that? Vroom vroom. Say engine sound, right? Engine sound. Say car has an engine sound of vroom vroom, vroom vroom, something like this. Okay. Boat has gur 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 gur, something like this. Train has zui, something like this. Airplane has whoosh, something like this, and motorcycle again has something, right? So the point is that again, vehicle class says that it should have an engine sound, but it doesn't say how exactly the sound should be. That's again the purpose of the child classes: the car, the boat, the train, motorcycle, and aeroplane. So vehicle is just a concept, it's just an idea. The methods defined within the vehicle are called abstract methods. So again, to recap, any class which is just a concept or just an idea is called an abstract class, and any methods, any method that do not have a body, like they do not have any body inside it, they are called abstract methods. We will be looking at practically, but yeah. Now the next question is, can I have some non-abstract methods? I mean, just the regular like normal methods. Yes, you can. Say every vehicle can start and every vehicle can stop. And say for example, you have defined the body over here. Say start. It will just print it out. It will just print it out start, and this will print out stop. Okay. So yes, you can have normal methods as well. And what about these normal methods? Well, these will be inherited. These will be inherited by car, boat, train, motorcycle, aeroplane. Okay. And what about these? These must be overridden. You remember method overriding, right? You have to do that mandatory. Okay. Again, now let's look at this. So we will be doing this in Java right now. So we have a vehicle abstract class. Vehicle abstract class has different types of method: abstract methods and the normal methods. Abstract method means they must be implemented in subclasses. They do not have a body. Abstract horn, method, body not defined. They do not have a body. Engine sound, they do not have a body. Why? Because these are to be independently implemented. For example, car would implement horn method and say it sounds beep beep. Boat would implement horn method and it would sound peep peep. Car would implement engine sound, it would sound vroom vroom. And boat would implement engine sound and it would sound gur gur gur, something. All of these has to be independently implemented. That's the method of that's the purpose of abstract methods. They must be mandatorily overridden. So overridden. So you absolutely have to implement these in the child classes if you are inheriting the abstract class. You must do it. Okay, you must do it. What about these methods? These are just the normal methods. You have studied inheritance, so you know what would happen. Car would have a start and stop, and what would these output? Vehicle start and vehicle stop. I haven't overridden these. Yes, you can override. You can override these things, but it's not mandatory. It's optional. If you really want to override this, go ahead, override it. If you don't want to override it, that's perfect. But these methods over here, they must be overridden. They must be. These methods, it's optional. If you want it to be the default implementation, then you're good. See, boat also has inherited start and stop, and they would be simply saying these things. So it can have normal methods, it can have abstract methods. These are called those those methods which must be implemented in subclass, the independently implemented ones, right? They are called abstract methods. And the normal methods are called concrete methods. Why concrete methods? Why concrete methods? Because these methods in this class have a body. It has some logic like this. System.out.println vehicle started, system.out.println vehicle stopped. It has a concrete body. That's why these are called concrete methods. And these guys, they do not have any body. Method body not defined. Method body not defined. Only this. Okay, no method body is defined. So that is the reason. They are called abstract classes. Abstract methods. Right. So vehicle itself is abstract class, and it also has some abstract methods. So whenever you are basically inheriting any abstract class, you must implement the abstract methods, and it's optional if you really want to override these things. By the way, you cannot create a vehicle. Remember, you cannot create a vehicle. Why? Because vehicle is just an idea, it's a concept. So you cannot create objects of an abstract class. Okay, so a brief summary over here. Abstract keyword: access specifier only used with class and methods. You cannot use it with variables. Okay, only you can have abstract class or you can have abstract methods. You cannot have abstract variables. Okay, now few more things. Yeah. Abstract classes cannot create objects of abstract class. You cannot create objects of abstract classes. Why so? I already told you, vehicle is just an idea. It's a concept. It's an idea. You cannot create a vehicle. Sure, you can create a car, boat, train. You cannot create a vehicle. Vehicle is just an idea. So you cannot create an object out of an idea, right? So you cannot create objects of abstract classes. That is the first rule. Let's talk about abstract methods. They do not have a body. They are open to independent implementation. Must be implemented in subclasses. This is very important. You must implement these, otherwise you will get a compilation error. Signature must match while implementing. I'll show you what that means. What about concrete methods? Just the normal methods. Methods with a body within the abstract class. They are called concrete methods. Just normal methods, okay? Overriding is optional. If you want to do it, just do it. If you don't want to do it, that's fine. These are just regular methods inherited from superclass. That's it. Simple methods, okay? Now let's quickly implement these things in BlueJ. Let's open up our BlueJ. Let me delete this. Okay, all right. Let's create a package first. Why don't we? Or let's not complicate things here. All right, let's just create a new class. Let's make an abstract class. Okay, let's say vehicle. Vehicle. Vehicle is an abstract class. Just remove how to create abstract class. I'll show you. Just remove all these things you don't need, and again just remove all these as well. Now over here, rather write abstract. That's it. That's all you need to do. Did you see? It changed. It changed. Just remove this. Just remove this. See? It changed again. The moment you put abstract over here, abstract, it changed into this. So this is how you would define an abstract class. Public is optional. You can put it over here, or you might skip it. But since for every class we make it public, just write public, and then say abstract class vehicle. Okay, abstract. Put this abstract keyword after public, or just remove public entirely. That's okay. But you have to write abstract class vehicle. Anyway, so what is our configuration? Let's check once. Can we just remove these things? Can I? Yeah, I can. Okay, all right. All right. So vehicle would be having two abstract classes. Sorry, two abstract methods: horn and engine sound. These are the abstract methods. Let's see what abstract methods are actually. So this is how you write abstract methods. Just say uh, again public abstract void. What was the method name? Quickly, horn and engine sound, right? So first write it like this: public abstract void horn, and put a semicolon. That's it. That's it. You're done. You're done. That's how you create an abstract method. Okay. You do not have to do something like this. You do not have to do something like this and start doing something. If you try to do something like this, system.out. Let me show you what would happen. Println something like this. If you try to do this, you know what it will say? It will say abstract methods cannot have a body. Abstract methods cannot have a body. So you cannot do this, right? You have to just remove all these things. Just delete this and just put a semicolon over here, and that's it. That's how you define an abstract method. You are done. What was our next abstract method? Yeah, this one, engine sound. Okay, let's implement it. Let's write it. Public abstract void engine sound. That's it. Abstract methods do not have a body. Okay, we are done with abstract methods. Let's write the concrete methods. Okay, these are the concrete methods. Why these are concrete methods? Because they do have a body. They do have a body. So start and stop, right? Vehicle started, vehicle stopped. Let's write. These are simple methods like you usually do. Public void start. It would simply say system.out.println vehicle started. And similarly you would have public void stop. System dot out dot println vehicle stopped. That's it. That's it. So these are what? These are concrete methods. Why? They do have a body. What is the body? This is the body, right? And what about these abstract methods? They do not have a body. Also must be overridden in child class, else compilation error. Okay, this gives an idea, right? These two give an idea to the child classes that hey, you must have a horn, you must have an engine sound, otherwise you will get an error. Okay, so let's save this, let's compile this. All right, and we are done. We have an abstract class vehicle. Let's create a new class. Let's call it the car class. The car class, and we are going to create the boat class as well. Okay, car and boat. Okay, car class and the boat class. Car. Okay, let's just first remove these things. Okay, simple class. Now you would how to inherit vehicle? Simply say extends vehicle. The moment you do this, it will show an arrow and it will show that there is some error. What is the error? It will say car is not abstract and does not override abstract method engine sound in vehicle. So you must implement the abstract methods. What are the abstract methods? Horn and engine sound. Okay, you must do that. So it says that you haven't overridden the engine sound method. and the horn method as well, but yeah, let's do that. You have to say at the get override. Again, this is optional. If you really don't want to skip the annotation, you can, but I'd say just put it over there. Okay, you can simply say public void engine sound. You can do that, and you definitely have to define a body for this. System.out.println. What is the engine sound of vehicle? I mean, the car. The car would go vroom vroom, something like this, right? We're done. Are there any other errors? Yes, there are other errors as well. Now what's saying? It's saying car is not abstract and does not override abstract method horn in vehicle. So again it says it has to override the horn method in vehicle. So let's override it. Public void horn, and what would it say? It would say system.out.println beep beep, like this, and we're done. Now it will not show any error. See, all the errors are gone. Why? Because you must implement the abstract methods. These do not have a body. Okay, so these must be overridden in child class, otherwise you will get a compilation error. Now you have implemented these independently. You have engine sound method, you have horn methods, these are overridden. Java is happy. Okay, but as long as you do not implement these in your child class, it will give you a compilation error. We have defined the horn method over here, we have defined the engine sound method over, and best practice is to just write it over here, that override. Just do it at override. Okay, that's it. Let's compile this and you're good. Now remember about this point. Okay, let's first do it. Okay, let's first do it. And you might ask, what about these two? Well, these are concrete methods. This will be simply inherited. You remember inheritance, right? This will be simply inherited. The moment you say start, stop, it will say vehicle started, vehicle stopped. So let's just keep the example and yeah, compile the car class as well. Let's take the entry point and let's make a car class over here. Let's remove all these things. All right. Let's have a car class. Car C is equals to new car. Doesn't have a constructor, so just use a default constructor. And now you have the car class. Try doing this. C dot horn, C dot engine sound, and since you know car inherited the vehicle class and vehicle had these two concrete methods as well, start and stop, this will also work. Start and stop will also work. Why? Because these were inherited as it is. So if you go to entry point and say C dot start, C dot stop, let's compile this and let's see how this works. Void main, run this, see what it's saying. So what's the first line? C dot horn, it would say beep beep. Why? Because this is how it is implemented, beep beep. Then you have C dot engine sound, this is how it is implemented, so you are getting this. Then the third line says C dot start. Now of course I haven't defined it over here, but since it extends the vehicle class and vehicle class has the implementation for start and stop, it will just say vehicle started when you call vehicle C dot start, and it will say vehicle stop when you call C dot stop. Why? Because these are literally inherited as it is, no changes. Okay, that's it. That's how abstract classes look like, and these are the abstract methods. Abstract methods do not have a body. Okay, great. Now what I was saying, you remember this point. Let's come back to this point once. Do you remember this point? I said signature must match while implementing. Signature must match while implementing. This basically means if I go in here, just see the abstract method over here. Does engine sound accept any integer or any double? Does it accept anything? It doesn't. It doesn't accept anything. Can I come over here and say something like this? Say for example, let's remove this. Okay, let's say I just remove this and I say horn, take some value, say int x. Will this work now? It will not work. Why? It will say you are not overriding the method horn in vehicle, although the name of the method is horn, but it will still say that you are not overriding this method. Why? Because the signature doesn't match. This method over here says I want an integer, but this method says I don't want anything. It doesn't accept any parameters. Whereas in here, you are saying that it needs an integer x. That is why the signature is not matching. This is the signature. The signature over here is just horn. And the signature over here is horn int. These are not matching. Even if you do something like this, override, this will not simply work. Even the compiler will now say the method does not override. Method is not overriding or implementing a method from a super type. It is not overriding. Technically, it is not overriding. Okay, so you cannot have this. You cannot have this. I mean, of course, say for example, you have a public, say for example, public void horn, and the signature matches somehow. You know, like this. Then that's okay. Why? Because the signature is not matching. This is horn without any parameters. This is horn without any parameters. The signature is matching. Now, when you pass an integer, into horn, that will be method overloading, and it will call this instead of this. And if you do not pass an integer, it will call this. So that would be method overloading. That's fine. But when you are extending an abstract class, you must implement the abstract methods over here, and those methods, those implementations must match the signature of the method. If horn doesn't accept any parameters, your horn should not also accept any parameters. If engine sound doesn't accept any parameters, your version of implementation of this engine sound must not accept any parameters as well. What about the return type? Can I change the return type? Well, let's see. If I do something like this, say public, not void, say for example, I say int, something like this. This will simply say method does not override or implement a method from a super. Why? Again, the signature does not match. Simply, signature does not match. Signature has to match. If I say it is void horn, it has to be a void horn over here as well. It can't have int horn. Yes, it can have in some different method over here. You can later create public int horn over here, and that's fine. But over here, this is not allowed. Even if I do something like this over here, this is not allowed. Why? Because car is expected to have this and this only. That means it must have void horn and without any parameters. So the return type must match, the number of parameters and its type should match, and the name should match. That's how you override things. Okay, so yeah, just remove all these things and we are good. Doesn't accept any parameters, so just remove this, compile this, and we are good. Now let's work on the other class, the board class over here, and let's close this window. And you know what, let's organize this. Let's keep it over here, this over here, and both of them are inheriting from this abstract class, so let's keep it over here. Looks neat, you know. Again, for this class as well, you got to remove all these things and these two, and just extend the vehicle class. You can say extends vehicle. The moment you do this, you will have another arrow showing up to vehicle, that is extending vehicle. But again, you get the same error. Why error? because you have to implement these two, the horn and engine sound. Okay, so let's implement these two. So public, oh, not over here, yeah, public void horn, right? Doesn't accept any parameter. You simply say system system.out.println. Board would sound like peep 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 peep, and yeah, also just type in that you're override override. You need to override another method, which was engine sound, right? So public void engine sound, and it also doesn't accept any parameter. Now you have to say system.out.println. Engine sound would be something like this, and you're good. So again, you are inheriting the vehicle abstract class, which is just an idea. And again, vehicle abstract class has two abstract methods, horn and engine sound, that you must implement, and you did implement both of them, so you don't see an error over here. And it also has these two concrete methods as well. So let's compile the board class and let's try it out. Let's go back to our entry point, and yeah, we have car. Let's create a boat as well. Boat B is equals to new boat. Again, just a default constructor. Oops, I think I should put it over here. Yep, this looks neat. Yep. So it basically says that it is using the car class and the boat class. I mean, it is not inheriting, it is just using. That's why you see the dotted lines. When it is inheriting or implementing, you will see this line, the straight, the solid line, and when it is just using it, you will see a dashed line, right? So b dot horn, c dot not c dot, b dot engine sound, b dot start, b dot stop, and let's compile this. We are good. Let's try run the entry point. All right, now let's see what's happening. First line, you create the car. Second line, the car horns, presses horn. You see beep beep. Then you see the c dot engine sound. It does its engine sound, vroom vroom. Then vehicle started, vehicle stopped. These are inherited from the parent class, which is vehicle. Now you create the boat object. Now boat does b dot horn. You get to see peep peep. Then boat does engine sound. You see gur 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 gur, something like this. Then you see b dot start, vehicle started, v dot stopped, vehicle stopped. See, these two are directly inherited from the vehicle class. These are because these do have bodies, right? They are directly inherited from the abstract class vehicle. These are called the concrete methods. These two have to be implemented. These are independently implemented. For example, if you see, in car this was beep beep, in boat this is peep peep, in car this was vroom vroom, in boat this was gur gur gur, right? So they both have engine sound and horn, but they sound different. They both of them have the same methods, engine sound and horn. They must override the abstract methods defined within the abstract class vehicle. That is the concept of abstract classes. So basically, abstract class gives you the idea, the framework to other child classes. Okay, this is all about abstract classes. If I go back, so basically this just gives you idea, the concept or the idea. You cannot create a vehicle object. Let's try to do that as well, just in case you go in here and say let's go back to entry point. and let's create a vehicle object over here. First of all, you cannot do it. If you say vehicle is equals to, say vehicle v is equals to new vehicle, try to do that, you will see an error. Vehicle is abstract, vehicle is just an idea, vehicle is just a concept. It cannot be instantiated, meaning it cannot have any object. It cannot have any object. So you will get a simple compilation error. You will not be able to compile this. Okay. So you cannot have an object of an abstract class. You cannot do that. Okay. Because abstract class gives the idea that car should have horn and engine sound, boat should have horn and engine sound. So that's a idea. That's a framework. You cannot create the child, like you cannot create an object of abstract class. That's something about abstract class. So again, this is the summary. Go through it once again. Abstract keyword can only be used with classes and methods. You cannot have a abstract variable, right? You cannot create objects of abstract class. Abstract methods do not have a body. They are open to independent implementation. Must be implemented in subclasses. Like the abstract methods must be implemented in subclasses. Signature must match while implementing. Okay, signature is another thing that you have to keep in mind. Then you have the concrete methods. Methods with the body within the abstract class are called concrete methods. That is start and stop, right? Both have methods in the abstract class. Overriding is optional. If you want to override, it's okay. You can go and override. They are just regular methods which are simply inherited from superclass. If you still want to override them, you can do that. Like for example, if I go to boat and I want to override start method, the start method, okay, instead of saying boat vehicle started, it would say boat started. If I want to do something like that, I would go in and it would say override public void start, and I would say system.out.println boat started. Okay, boat started. If I want to override this, that's fine. I can compile this, and let's also override the stop method, right? Override public stop system.out.println boat stopped. Okay. Overriding, overriding start and stop are optional. Why? Because start and stop are, again, they're concrete methods. They already do have a body, so you don't need to like mandatorily you don't need to override them. Okay, but you can do it if you really want to. Let's compile this. Let's go back to entry point. Let's compile this as well, and let's run it once again. As you can see, for car it is the default one, vehicle started, vehicle stopped. But since I have overridden these two methods in boat, you will see boat started and boat stopped rather than vehicle started, vehicle stopped. So this is all about abstract classes. Now let's go back to the next concept. What's this? Isn't it what I've already shown you? Yes, it is. But it is something different. Now we are going to study something known as interfaces. What is the interface? What is the interface? If you go by definition, it is basically abstract class minus concrete methods. Okay, into what are interfaces? Interfaces are just abstract classes, but without concrete methods. That means for abstract classes you had the concrete methods over here. You had the concrete methods, and those were inherited by this, right? But for interface are also like abstract class only, but without concrete methods. For interface, you do not have any concrete method. You do not have any concrete method over here that will get inherited or something like that. It is pure abstraction. Pure abstraction. Okay. This is like if I go by definition, interfaces are basically what? They are uh, semi-abstract. They are semi-abstract. Abstract. Let me. Sorry, wrong. Yep. For abstract classes are semi-abstract, whereas interfaces are completely abstract. Okay, that's the difference. Interfaces are completely abstract. Interfaces cannot have concrete methods. It cannot have any method that has a body. That is interface. There is no more difference over here. Again, if we go by the same example, the vehicle and the car and the boat class, vehicle is now an interface. Vehicle is now an interface. Vehicle is now an interface. Simple. Okay, and vehicle has again these two abstract methods, abstract horn and abstract sound engine sound. Okay, these two, and it has been implemented, not inherited. Interfaces cannot be inherited. They are implemented. I'll show you what that means, but think of it like a class, just an abstract class. Interface is just an abstract class without the concrete methods. Okay, that's it. Same thing. Car will have horn and sound engine. Boat will have horn and sound engine. That's it. Simple. Okay. No difference over here. No difference over here. Now I'll show you how to create abstract class in BlueJ, and I will also show you how to create abstract class in general without using an IDE, just using a notepad or just a text file. I'll show you that as well. Alright, so let's go back to BlueJ and let's start coding. Let's close this out and let's create a new class. Let's just close this, and I don't need any of them at the moment. I'll create them once again, so I'll just in fact, let's have another like this. Let's call it entry point 2. Let's call it entry point 2. Let's have it over here. Let's have a car class and boat class, but we already have the car class, so let's call it car 2 and boat 2. Let's call it boat 2. We have the car 2 and we have the boat 2. Then let's have a vehicle interface. Now how do we create an interface in BlueJ? So you basically do it like this. You click on this new class, and over here select interface rather than class and just write the name. And since we already have vehicle, yes, we can have vehicle interface because this is a class and this is the interface, so you can simply say vehicle. This would also work, but let's let's not do this. Let's call it vehicle 2. Okay, and we have the vehicle 2 interface. Now remember, like I said, interfaces and abstract classes are almost the same thing, except for one thing. By definition, abstract classes is not fully abstract. Okay, it can have abstract methods, but it can also have concrete methods, whereas interfaces can only have abstract methods. So what is interface? Once again, interface is basically abstract class minus the concrete methods. That is what interface is. So we can only define concrete methods over here. And how does the code look like? Code looks like this: public interface vehicle 2. So you type in public, then you write the keyword interface, and then vehicle 2, whatever your interface name is. Okay, let's remove all these things, and it works exactly like an abstract class, just that it cannot have any concrete method. So you can have void horn, that's it. And you can have void engine sound. So now there might be this question, why are you not writing public abstract before this? Can I write this? Yes, I can write this, but you know what, by default, like it is there already. You don't have to write it, you don't have to explicitly mention it over here. When you are working with interface, every method is by default abstract and public. Whenever you are working with interface, every method is abstract and public. So just remove this part, you don't really need it. Even if you define it, it's not wrong. You can exactly define it like you defined in abstract class, and it will work. But why define it? I mean, it's already there, so just remove this and you're good. So you don't need to go in there and say public abstract. You don't need to do this, it is already there. So it's even easier when you're trying to do such abstraction. Yeah, that's it. But you cannot have something like this. You cannot have public void and say you have another, say for example, what was that, start. You cannot have something like this. You cannot do it. Interface abstract methods cannot have body. Okay, so basically you cannot have any method that has a body inside an interface. So you cannot do this. The only thing that you can do by definition is this much: just create the abstract methods, and these are abstract methods. Although I'm not writing abstract over here, but still these are abstract methods, because by definition interface can only have abstract methods. So these are public and these are abstract. Okay, so yeah, that's it. Let's compile it. It's compiled. Let's go back, and for car2, again remove this. And you know what, it's the same thing, so I'll just copy and paste. It's the same thing. I'll just rather copy this, paste it over here. It's the same thing. Paste, and yeah, let there be. Now one important thing is that, okay, before you do this, let me go till this side. Yeah, how do you inherit an interface? My point is, how do you inherit an interface? Why I'm saying this? Because this is an interface, not an abstract class. A class you can simply say extends vehicle, vehicle, and it will basically inherit this. Okay, it will inherit this. If I just go over here, you can see this is inheriting this class, but I am trying to inherit this, and this is not an abstract class. This is not even a class. This is an interface. You cannot extend an interface. What you can do is implement an interface. So you have to write public class car2, which is this class, implements this interface vehicle 2, and suddenly you get an error over here. You can see this arrow, and do you see this dotted arrow? This means, and you see the end is triangular, so looks like this only, but there is a dot over here, dashed arrow, right? Do you see the difference? This dashed arrow means that this is getting implemented, not extended. You can only extend classes, you cannot extend interfaces. Interfaces you have to implement. This is how you do it. And what error it is giving? It is saying car2 is not basically implementing the methods in vehicle 2. So what this is saying is that vehicle 2 has horn and engine sound, and car2 doesn't have it, so you have to define it. Like it's mandatory. Whenever you implement an interface, it is mandatory to define the methods, because these are exactly like the abstract class and these are exactly the abstract methods only. Okay, there is no difference. It is basically public abstract void horn and this is exactly public abstract engine sound. So you have to implement both of them over here. So let's implement the first method, which is public void horn. This goes system.out.println and this is beep beep this, and you're good. But there's another error. Now it says engine sound is not yet done, so let's do that as well. Public void engine sound system dot, oops, vroom vroom. Okay, like this. Um, and we are good. The moment you do this, you don't see any error anymore. But yeah, it's a good idea to always, override. And again over here, override, because you're technically overriding the horn and the engine sound method, which is defined over here. These are abstract methods, they do not have any body, and these are the implementation of those abstract methods. We are done. Let's compile this. This looks good. Let's use it in the entry point. So the next question might be, can I have an object of interface? Can I create an object of interface? Let's try it out. Let's see what happens. Let's first define the main method. Public static void main string args, and let's try doing it. Vehicle to v is equals to new vehicle 2. Is this even possible? Is this even possible? See, if you see this, it is trying to use it. It is trying, at least it is trying to use it, but it will not work. It says vehicle 2 is abstract. Just it's the same thing like this. Remember the same thing. Even if you try to create an object of this, it will say the exact same thing. Say this vehicle vx is equals to new vehicle. Do you see? It is now trying to use this, but again, same error. Vehicle is abstract, cannot be instantiated. That means no object can be created. Vehicle 2 is abstract, cannot create an object. So they are basically the same thing. Interface and abstract are basically the same thing. By definition, interface do not have any concrete method. That is the only change. Anyway, let's go back and let's just remove all these things. Let's write our code, which is pretty basic. We create a car2 object. Car2 is equals to c new car2. We use the default constructor. Okay, it is using it. Now you simply say c dot, what were the methods? Horn and engine sound. So just do that. C dot horn, C dot engine sound. Okay, done. It doesn't have any other method because it cannot inherit anything from this interface, right? It cannot do that because by definition interface do not have any concrete method. So you cannot have concrete methods like this. Do you now see the difference over here? Let me just remove the comments. Do you see the difference over here? This is vehicle, this is an abstract class, whereas this is not this actually. Yeah, see the difference. This is vehicle. This is the vehicle abstract class. This has horn and engine sound abstract method. This also has horn and engine sound, but you don't have to explicitly define public abstract like you do in abstract classes. You don't have to do the same in interface. By default, it is there. By default, it is abstract and it is public. So no need to define. Another difference is that abstract classes can have like the concrete methods. You can have methods that do have body, and they can be inherited by your child classes. But in vehicle 2, which is an interface, you do not have any concept like that. You cannot have any concrete methods that can be inherited. So that is the only difference between interface and um, abstract classes. And of course, if what happens to variables, if you try to define something, let's see, int x, if you try to do this, will you get any error? Yes, you will get error. What? Int x equal to expected. So you cannot just put int x over there as a property. You cannot do that. Rather, what you can do is int x is equals to 10. If you do this, see what happens. Let's see what happens. First of all, though, let's remove this at the moment, and let's save this and compile this, and let's first run this. Let's compile car2 as well, or run this entry point. Yeah, this is already there. Compile this. Let's run this entry point. Yeah, I'll show you that later on. Oh, did I not clean this? Okay, let me run this once more. Entry point 2. Beep beep, vroom vroom. See, horn, beep beep, engine sound, vroom vroom. Pretty simple. Pretty simple. Nothing to complicate the thing. All right. So let's do the same thing for the boat 2 class as well. So we need to go here. And since this is the same thing as the normal boat class, right? Except it was overriding the concrete methods as well. But I can copy from here to here without any problem. I can just copy this. Copy. Go to the boat 2. Paste over here. And over here just write in implements. Hey, just remember this. You are implementing an interface. So don't write extends vehicle 2. It implements this interface. So whenever implementing interface, you have to write implements vehicle 2 and compile this. See, it is working. It is good. Let's create a boat object as well over here. Boat 2b is equals to new boat 2 b dot horn b dot engine sound. Let's compile this and let's run this. As you can see over here, beep beep, vroom vroom, this is the car. Beep beep, grr, this is the boat, right? So that's how you work with interfaces. It's the same thing, just that you don't have concrete methods. Okay, good. All right. So what about the case where I was saying in vehicle 2 you have an integer variable, say int x is equals to 50, for example, and let's save this and let's compile this. Let's compile car 2 and boat 2 as well, and entry point 2 as well. Okay, can I try to access the x? Can I say b dot x, and will it give me the right result? It will not. What about system dot out dot println? Will this work? Well, let's try it out. If it gives us 50, we are good. Let's compile it. That's compiled. Let's clean this before running it. As you can see, you are getting 50. So yes, you can have certain values. You can have certain values over here, and you can access it using the object. For example, here we created the boat object and we are trying to access the X variable. Can I access it? Yes, I can access it. Can I do the same thing for C as well? C is a car, right? Can I do the same as C? We just copy this and paste it and do C dot X. Now, the thing is that both C and B, C is a car object, B is a boat object. Both car and B are implementing vehicle to interface. They are both implementing the vehicle to interface, and vehicle 2 has X is equals to 50. So technically, both the car and the boat should access X. So let's see if this is the case. Let's clean this up, start to run it. If there are two 50s, we are good. Yep, both are having the same property and they can access it. So this is what interface can do. Okay, let's just remove this for the moment. All right. So can I do the same thing? Can I say int x is equals to 50 in abstract classes? Well, let's see. Let's try it out. Let's clean this up. Close it. Over here. Oh, this is the abstract class, right? Can I do something like this? Int x, just this. Can I do it? Yes, it will allow me. It will take it as a property. Okay. Like, say I'm just compiling this. Compile. Car class compile. Compile this. Entry point. Say entry point. Well, let's try to access X from C. Can I do it? Say for example, I want trying to print system.out.println and I want to access C.X. Can I do it over here? I compile this. Class compile, no syntax error. Let's run it up and let's check. Zero. Why 0? Well, the default value for integer variables is 0. If you do not instantiate it, for example, in the vehicle abstract class, I haven't initialized any value to X. So by default, any integer variable will have the default value of 0. So that's why I'm getting a 0. I can do it X is equals to 50, and that will also work. So no issues at all. Okay. And by the way, just to clear out the cloud, you can have static attributes, you can have static methods, all of that in here, but you cannot have static abstract or something. You cannot have public static abstract void test. You cannot do something like this because it will say illegal combination of modifier abstract and static. You cannot have static abstract or something, some weird thing, right? You cannot do that. So just remove this and again remove this as well. Yeah, we are good. So that's about interfaces and classes. And again, let's just remove this for the sake of clarity. Compile. Let's compile everything, right? We were working with the board class, right? Control Z this. Yeah, this looks good. Yeah, good. Just close this. So as you can see, interfaces and abstract classes are similar things, just that interfaces gives you complete abstraction. You cannot have any concrete method. All the methods are abstract. That's why it is called complete abstraction. Whereas in abstract classes, you can have abstract methods and some concrete methods. That's why it is semi-abstract. It is not fully abstract. Okay, that's the only difference. So we are done with interfaces. Let me show you how to create interfaces without using BlueJ. Like BlueJ is just a toy, it's an editor. But what about actually creating some interfaces in the outside world. Let's come back. This was where I taught you packages. Well, what about a new, okay, let's open this in VS Code. Not like this. Okay, we have this thing. Let's create a new interface. How do we create a new interface? Nothing, just create a file like you do and just name it. Name it maybe vehicle dot java. Don't write interface, just write java. And rather than this, do it like this: public inter vehicle. Just do this. Public interface vehicle. Just do this. Just write it. And yeah, just type in this void horn and void engine sound. Like it's the same code that we are doing, right? Just save this up. This is done. Just compile it like you do. Call the javak and compile the vehicle.java. That's it. You get it. Now, although it is showing you, although it is an interface, it is still showing you as a class, because by default, it is anyway like what is this? This is still a Java thing, right? It is still the bytecode. So you will see this dot class, but it is not actually a class. It is an interface. This is a bytecode. Even in bytecode, you will see interface. Okay. So yeah, that's it. Let's review some more topics. Well, can interfaces have concrete methods? I already answered that. Interfaces cannot. They cannot have concrete methods. Okay, they cannot. But this was true till Java version 7. This was true till Java version 7. They cannot have concrete methods, and that was by definition. But this was true till Java 7. Okay. From Java 8 onwards, interfaces can have concrete methods. And static methods. So this is the big thing. This is a big thing. From Java 8 onwards, interfaces can have concrete methods and static methods, which was not allowed till Java 7. So till Java 7, interfaces cannot have concrete methods, and that was true by definition. But from Java 8 onwards, even interfaces now can have concrete methods and static methods, which basically defeats the whole purpose of having interfaces, having the difference between abstract classes and interfaces. But it is what it is, right? We can't do anything about it. So yeah, let's see how we can write concrete methods in interfaces. There is a difference. You cannot just go in and type in void and start doing coding. You cannot go ahead and simply say void start and start typing in. That will give an error. Interface abstract methods cannot have body, because that was by definition. But only one change over here, and you can actually write concrete methods. Just say default. That's it. Do you see the red mark is now gone? The red mark over here is now gone. It will not show any error. So for writing concrete methods within an interface, all you need to do is write the method signature, whatever you are doing, but just add default keyword before it, and here you go. You have the concrete method. You can now say simply system dot out dot println. You can say vehicle started, and similarly you can have default void stop system dot out dot println vehicle stopped, and both of them will work. In fact, from Java 8 you can have static methods as well. For example, I cannot think of an example, so just create one. Static void example system dot out dot println. This is a static method from interface. That's it. We're done. Okay, I can compile this and this will work. You see, no issues at all. So question is, can I use start and stop? Yes, you can. Do I need to like now inherit it? No, you don't need to inherit it. You are implementing an interface, and this will still make sure that you still inherit start and stop methods from here. Okay, you are not defining start and stop over here. You are just defining horn and engine sound. You are not defining start and stop, but you still have those methods, and I will prove it to you. Let's compile this, go back to entry point and check it out. Let's remove all these things. I can now do c dot start, c dot stop. This will work. B dot, oopsie, I missed a semicolon. Yeah, B dot start and B dot stop. They will work. Now if I compile this, and yeah, I have that static method as well. Right? How do you call a static method? You put the class name, and the method name, right? In this case, type the interface name vehicle to dot what was the method name? Example, static method, right? And this, by the way, will work. This will actually act like a static method. And now if you see clearly, there's another arrow that is going over here because it is accessing the static method of this interface, and now the interface is almost acting like a class. Remember how we used to call the static methods class name dot static method name? Similarly, we are doing over here also, although this is an interface. Let's compile this and oops, this is dirty. Let me just yeah. So beep beep, vroom vroom, this all good, but now you have start and stop, and you see this vehicle started, vehicle stopped, which by the way I haven't defined in car2, right? And you also see for boat as well, you see peep peep and gurgur, but you again see vehicle start stopped, which again I haven't defined in this boat 2 as well. Let me open boat 2. I haven't defined it anywhere. So how is this working? Isn't it the same as in inheriting things? Isn't it inheriting the methods? Yes, they are inheriting this. They are inheriting the methods from here. From the interface, they are basically inheriting. Although I'm saying implementing, it is still inheriting these methods. Okay, that's how it is working. It is now exactly working like an abstract class. This is surprising, isn't it? And it also has this static method which is getting accessed directly. The interface name dot the static method name, and you can see this is the static method from interface which I have defined over here. So it's all working together. So now there is really not much of a difference. If I open vehicle 2, which is an interface, and then I open vehicle, just the vehicle one, which is an abstract class. Do you see there's not really much of a difference? Yeah, just the static thing. If I just remove this, just compile this, what do you see? Not really much difference, is it? Compile this, see, not much of a difference. Yeah, both are having abstract methods, horn and engine sound. They are defining concrete methods like this, you are defining concrete methods like this, but anyway these are concrete methods. Okay, so this is the big change. This is how you can have concrete methods in within interfaces from Java 8 and later. All right, let's go to the next topic. The next question is, can we achieve multiple inheritance using interfaces? Can we do that? Well, the quick and easy answer is yes, we can. We can absolutely achieve it. See, technically you cannot do something like this. Say you have a class, say you have a class Y and you have a class, okay, let's have a class A and a class B, okay, and there's a class X. Now, can it extend A and C together? Can it extend? Look at my words, extend both A and C. It cannot. Why it cannot? Because Java does not allow multiple inheritance. Doesn't allow multiple inheritance. But and by the way, these are what? Class A and class C, and this is also a class X. Okay, now just look at different scenario. Say we have A and we have C, and again we have X over here, and A is an interface and C is also an interface, and X is a class. X is a class. Now, can it implement A and implement C? And I'm not saying extend, I am saying, can it implement? Yes, it can. It can. And now that you know, the interface can have default methods, right? It can have concrete methods. Class can also have concrete methods. So that means, yes, you can achieve multiple inheritance via this process. Yes, you can do it. Okay, you can have two interfaces and you can implement both of them. You can implement more than two interfaces. For example, you can say something like this. See, look at this. You cannot say like this, class A extends B comma C. This is not allowed in Java. Okay, why? Because Java doesn't allow multiple inheritance, and this is inheritance because you are extending B and C. But if B, and by the way, B and C are of course classes, they are classes. Okay, but this is allowed. Class A implements B, C, D, E. It doesn't matter how many interfaces do you have, as long as they are interfaces and you are implementing them rather than extending, implementing them, that is perfectly allowed. So can I combine both of them? Yes, you can combine. You cannot inherit more than one class, but you can implement more than one interface. So can you combine both? Yes. So you can also say class A extends B, implements C, comma D, comma E, comma whatever you like, how many times you like. So here you are combining both of the things. A is extending class B. B is also a class. And it is implementing C, which is an interface, D, which is an interface, E, which is an interface, and how many times you want. Okay. There is no limit. So yes, a class can inherit and implement at the same point of time. You can do it. Okay, you can do it. Let's just see some quick examples over here. Okay. Okay. How about this? Let's just close all of these things. At the moment, we don't need it. And yeah, just remove everything over here. Delete. I don't need this one as well. Delete. And yeah, we're good. We just have entry point. Let's remove all of these things. Oh, not the main method, of course. And yeah, and this looks good. Compile this and we are good. Anyway, let's create some classes. Why don't we? And oh, in fact, let's create some interfaces rather. uh, Interface demo A. Let's create a new interface, demo B. We have demo A and demo B. Now let's create a class which is the demo class. We have demo A interface, we have demo B interface, and we have the demo class. And say for example demo A, so all of these things. Demo A has a default method. I'm not going into abstract methods at the moment, just saying default method, just to show you that yes, multiple inheritance is absolutely possible. So default void example. Example is a method. It has a body which says system dot out dot println example from demo A interface. Okay, it just says this, let's compile this and let's go to this interface, demo B. Again, just remove these two, and default, it again has a default method, default void example 2. Why did I keep example 2 instead of example? I'll show you that as well, but for now just say this, system dot out dot println example 2 from demo B interface. Okay, compile this, we're done. Let's bring them together over here. Okay, looks good. All right, let's go into demo class and remove it technically, and let's call it, let's have another method over here, of course not default because it is a class, so I can say void public void and example 3. Okay, system dot out dot println example 3 from demo class. Okay, just the three things over here. Let's compile it up. and let's go to entry point. Yeah, okay. Let's create a demo class object. Demo class D is equals to new demo class object using the default constructor. And of course, demo class basically implements, I'm not saying extends. Why? Because they are interfaces. They cannot demo class cannot extend them. Demo class can implements. Now you will see multiple inheritance. Demo A comma demo B, and boom, here you go. That is multiple inheritance in Java using interface. Using interfaces, you can achieve the same functionality. Say you are implementing demo A and demo B. Demo A has this method example, demo B has this method example 2, and the demo class itself has example 3. When in entry point you are creating the demo D, like demo class D object, you can access all 3 methods. You can say example, you can say example 2, which is in demo B, you can say example 3, which is in demo class itself. Okay, let's compile it. Let's try it out. There is a small issue over here. Yeah, looks good now. Compile, run this. Now see this. The single object can inherit methods from multiple interfaces, right? It has d.example, which says example from demo A interface. That means this method is coming from which interface? Demo A interface. Then you call d.example2. It says example2 from demo B interface. That means this method is coming from demo B interface. And then finally you have example 3, which is defined in its own class. It is defined. If you see over here, it is defined in its own class. So this is from demo class only. So there you go. This is multiple inheritance. It is inheriting from this also. It is inheriting from this also. This would not have been possible if this is, I mean, if this was class. Okay, you cannot do multiple inheritance in class, but you can definitely implement multiple interfaces. That is absolutely possible using interfaces. That's how you do multiple in. You can achieve the same functionality as multiple inheritance. Okay. In fact, let's say you have a class. Let's say you have class, and it is a normal class. Let's call it demo C. We have a class over here. Okay. Let's put it over here. Freshen it up. Close it. Let's go in here. So this is our demo C. This is a class. This is not an interface. So just remove these two. Say for example, it has public void example 4, and it says system dot out dot println example 4 from demo C class. Okay, demo C. Okay, now can I go in the demo class and basically extend demo C? Yes, demo C is a class, is a proper class. You cannot implement demo C, but you can definitely extend demo C. extends demos. There you go. There you go. Now do you see? This is how you can achieve multiple inheritance. You can, yes, you can, of course, you can only inherit a single class, but you can implement multiple interfaces. You can implement multiple interfaces. You can have demo A interface, demo B interface, demo X interface. You can have multiple interfaces over here, but you can only extend only one class. So now, by the way, now demo A has example method, demo B has example 2 method, you yourself have example 3, and demo C has example 4. Now if you go into the entry point over here and say d dot example 4 and just type in over here, compile this and run it. Now you see example from demo A interface, example 2 from demo B interface, example from demo class itself, example 4 is now coming from the demo C class. So this is how you achieve similar functionality as multiple inheritance. It is extending demo C, implements demo A and demo B interfaces. Perfect. Great stuff. All right. Let's move on to, and before going there as well, let's see one more thing. Say, look at this. I am not going to implement it or write the code. Try to do it on your own. Say you have a vehicle class. This is a normal class, no abstract class. It has a constructor vehicle, it has a property int registration. Just say it, int registration. Registration is the your vehicle registration number, say 84213 whatever. That is a registration number. It has a start method, and yeah, both of them are concrete. Write some body, write some body for it. Say car starts or vehicle starts, whatever. Okay. This is a normal class, not an abstract class. Yes, of course you can make an abstract class, that's your choice. There is an electric interface, and both of them again are concrete methods. This is an interface. Charge, discharge. Electric vehicles will charge, electric vehicles will discharge. You have another interface. This is another interface. Convertible cars. You have seen the cars which have hoods, right, that do open and then they do also close. So these are again concrete methods. Okay. Now you have a class called convertible electric car. This implements this and extend this class as well. Now you create a constructor of its own, and this will call the super constructor, which is basically this one over here. It will create an object of it. Okay, it will create a convertible electric car object, and now convertible electric car will have this method, this and this as well. You can try and doing that in BlueJ on your own, so that you will learn it easily. Let's go to the next topic, which is inheritance in interfaces. What about inheritance interfaces? Can interfaces inherit from something? Well, let's see. Before that, remember I told you that it cannot have example, same method you cannot have. So what will be the problem? Let's go to demo and just remove everything over here. For now, just remove everything, close everything. Let's not focus everywhere. And let's come over demo A. Demo A has example, demo A has example, demo B has example 2. What if I say demo B also has example and compile this? Now demo A has example, demo B has also example. Demo class, say for example, I just remove this method and simply say it implements demo A and also it implements demo B. What will happen now? It will cause error. Why? They are incompatible. Why they are incompatible? Because now the Java compiler is confused. Demo A also has example, demo B also has example. So which one to override? Demo A's example or demo B's example, right? That's why it will not allow you to implement interfaces which has same name methods, right? It will not allow. So that's the thing, that is a problem with interfaces. Okay, like this was the, in fact this was the only thing about multiple inheritance, right? And this is solved over here. You cannot have same methods, exact same method with same method signature in both interface and expect it to work. It will not work. Okay, we'll get an error. With that, I will say the question is that can an interface inherit from other classes and interfaces? Can I do it? Say for example, you have a interface A and interface B and class C. Okay, and you have an interface X. Now can X implement this, this and this? Can it implement? Or is it extend? Because we are working with inheritance in interfaces, not in classes. So is it implement or extend? Let's go back to BlueJ again. And yeah, let's delete these things at the moment. Save this, compile this. For now, just close this. And let's say this is the interface. My question is, can it inherit demo C? Can it do that? Let's try. So this is demo A. Can it extend this class? This is the class, so it has to be extended. So can it extend demo C? Can it do this? Extends demo C. What will happen? Interface expected here. So technically it says you cannot inherit a class. If it's an interface, you cannot inherit a class. You can inherit another interface. So I can write demo B over here and this will perfectly work. See, it now works. So an interface can extend, that is inherit another interface. That is perfectly possible, but it cannot extend a class. So you might say this is an inheritance. Why is it extending or inheriting that interface, right? Shouldn't this be implements? Shouldn't it be this? What does it say? It says this is wrong. It doesn't say the entire thing, but it says this is wrong. So let's understand this in a bit detail. First question that you should ask yourself is this: what is an abstract class? Sorry, what is an interface? What is an interface? What is interface? It's an idea or concept, correct? It's an idea or a concept. Okay. My question to you is, can an idea implement another idea? I mean, this is kind of philosophical, but here's my question: can an idea implement another idea? No. It's just an idea. It does not exist in reality. It does not exist in a physical form. It cannot implement another idea. But But if I say, can an idea take inspiration from another idea? Can an idea take inspiration from another idea? Yes. Can an idea implement another idea? No. Why? Because it's an idea, it's not something in physical. But can an idea take inspiration from another idea? Yes, that is possible, right? Both are just concept. You can take one concept and create another concept from it. So technically, this means extend. Taking inspiration means inheriting the properties of another idea. Can an idea inherit properties from another idea? Can an idea extend another idea? Can an idea take inspiration from another idea? Yes. That means if you have an interface A and interface B, you cannot say A implements B. You cannot say this is wrong, but you can say A extends B. Why? B is the idea, A is another idea. Now A extends B. Okay, A takes inspiration from B, A is inheriting B. That is very much possible. So let's go back and see how it works. So we can say interface demo A extends demo B, and that will actually work. Now, taking a closer look, demo B has example, demo A also has example. So which one will be used? Which one will be? Demo A also has example, demo B also has example. So which one will be used? Let's compile both of them. Let's go to demo class. That basically implements for this guy. It has to implement the demo A, like demo A implements. Yep, it has to implement the interface, because this is itself a class, right? Class has to implement an interface, but an interface has to extend another interface if it really wants to. Okay, so for class it is implements, for interface it is extends, and it can only extend interfaces, it cannot extend classes. Okay, coming back over here, let's not have any method. Let's compile this. Let's go back to entry point. So see the arrow, entry point is using demo class. Basically it is creating a demo class object and all. Demo class is implementing interface demo A, which is extending demo B, which is another interface. This is the workflow. Okay, so let's delete all these things. Let's call d dot, oops, these do not exist anymore. Let's just delete all this. D dot example. Let's compile this. If I try to run this now, look at this. It says example from demo A interface. Example from demo A interface. But it could have taken example from its parent also. Its parent also has example. Why is it taking from demo A? Demo A has example, demo B also has example. So why is this getting used? Any idea? Any idea? Well, very simply, this is simple method overriding. Remember, your parent has a method which is called example. Its child has the same method called example. That means you are technically overriding. Technically, you are overriding demo B's method. So you are overriding this method. Where you are overriding this method? Where? In your child class. Sorry, child interface. So you can actually override your parent interfaces method in your child interface. Okay, if I have to summarize it, if I have to summarize the whole thing, I simply say these things and go in over here, say an interface can inherit or extend another inter interface only. Okay, another interface only. It can, yes, it can extend, but only another interface. Got it? So that's the concept. All right. Also, an interface can override its parent interfaces properties, attributes, or both attributes and not just methods. Attributes and methods. Interface can override its parents interfaces, attributes, and methods. Got it? So this is the concept. What about overloading? What about overloading? How about we touch that concept? So what I'm trying to say is this. Let's again just remove these things. Let's just remove all these things. Extents. Okay. Doesn't override anything or something. Okay. Can I have method overloading here? Can I say default void example int x system.out.println the number is whatever the value of x is, this x. Can I do this technically? uh, Default double example double x double number is x. What is there over here? Missing return. Okay, I'm missing the return statement. Lol. uh Maybe return 56.234, whatever. Is this okay? Can I do method overloading within interface? For default methods, for concrete methods, can I do it? Well, why don't we try it? The best way to test anything is to try it out. Let's go to demo class. It implements demo a interface, and okay, let's not have any method over here. Let's just compile. This is the empty class. Everything it is getting inherited from the interface. Let's go to entry point. Let's try it out. Why don't we do something like this? Just the example d dot example 5. This is an integer, right? Let's try if method overloading works here. Yep, as you can see, example from demo interface, the number is 5. The number is 5. So that means that method overloading is actually working. If you don't pass any argument, this will be called. If you pass an integer, this will be called. If you pass a double, this will be called. So you can see method overloading is perfectly working fine. Great stuff. Great stuff. All right. With that, we can conclude this as well. Interface can have overloaded methods. An interface can have overloaded methods. Okay. Okay. But what about, you might ask, is this only for the default, I mean the concrete methods, or is it also for the abstract methods? What about this? What if I say void example abstract method? I can say void example int. Now what? And if I int x, okay, int x void example, or maybe double example double y or x or whatever, right? What about this? See, previously it was all concrete methods. You are doing method overloading. Cool. What about this? Okay, this is compiled successfully. That means you have to implement this signature, this signature, and this signature. You have to implement all of this if you are inheriting this, if you are implementing this interface. So again, let's go back to demo class. You are implementing demo A. Now see what is saying. You have to implement all of that. So let's try to do that one by one. Public void example. Don't pass any argument. Don't do anything. Let's keep it empty. Or let's do one thing. Let's say system.out.println example from demo A, and of course override. Just override it. Yep. Still you are getting error. Now it says you have to implement this one. Override public void. What were the signatures again? Void example. This is implemented. Let's implement this thing. So I can say public void example int x. You can also put a, that doesn't really change the fact. System dot out dot println example number. You can put in a, like you have taken a, so just a over here. Still it is showing error. It is now saying to implement that one. So I have to implement everything over here. Now I have to implement this one, double x. Public void example double x, whatever. You can put whatever identifier you would like to. By the way, this would be public double example. Again, example number whatever plus x. Return something, say 12.34 something. Okay. And this shall work. So when working with method overloading, it will work on both the default concrete methods in interfaces and also the abstract methods, and this is the same thing for abstract classes as well. Okay. Now looking at the next topic, one second. Oh yeah, just to add, this works for both abstract methods and default methods and static methods as well. Oh, by the way, default means concrete, right? Concrete methods and static methods. This works for all. Polymorphism in interfaces, yeah, this is all we have talked about in the previous scene, right? Method overriding works, method overloading works, okay. Of course there is no point of constructor overloading, because anyway, what was constructor overloading? When you create, you needed constructor when you create an object. You create an object, you need constructor. But it's an interface. It's an interface. You anyway can't create an object of interface. So constructor overloading, constructor overloading, this doesn't work. Okay, let me write it in a better way. So what doesn't work? So two things: constructor overloading, because interface can't even have a constructor, let alone doing constructor overloading. How can it have constructor overloading? It is an interface. You cannot create an object of interface. So this is not possible. And operator overloading. Operator overloading is anyway not possible in Java, and also since we are not creating an object, what would you do addition with? What would you do multiplication with? So anyway, these are not allowed. Okay. So these two things are not allowed. Okay. So we have finished polymorphism interfaces. Last topic. Last topic. Okay. Say you have a class called demo child class. It has a method called test. You have a parent, you have a super class called demo parent class. It has again a method called test. You have an interface called demo interface. It again has a method called test. Now demo class extends this super class and implements this interface. Now say for example you create a object called d for demo class, demo child class. Now when you call d.test, which one will be called? This one, or this one? Let's see. Quickly do this, and this is the last topic. After this we'll be ending the video. We are very close to completion. Again, let's clean this up. Close this, and yeah, let's start from scratch. Say demo A has a test method, okay, and I'll be working with the default methods at the moment. Default void test, and it simply says system dot out dot println test from demo A interface. Compile this. This is done. You have a demo C class. This is a class, by the way. Okay, this is a class. Again, this has a test method. All this public void test, and this would say system dot out dot println test from demo C class. Okay, and now let's go back to this one. Let's remove everything over here. And let's remove this one. So first things first, it will, and yeah, by the way, just delete this at the moment. I don't want it to cause any confusion. So at the moment you have a parent class and you have a parent interface. Let's extend the class and implement the interface. Extends demo A, sorry, extends demo C, this is the class, and implements demo A. Okay, implements demo A. Cool. As you can see here, see, this is dashed, this is solid line. Dashed means implement, solid means inherits, extends, right? So again, public demo class itself has a test method. Say public void demo. It will say system dot out dot println test, sorry, test method, right? Yeah, right. Yeah, test from demo class. We're done, right? What about this? Compile this, compile this. Let's run it. So we already have a demo class object. Let's call d.test and let's see what it calls. Oopsie. Test from demo class. That means it is calling the test method from itself. This one. What happens if I remove it and then compile it? What happens then? Compile this as well. And now let's run this once more. What happens now? Now this is calling from demo C class. Demo C class, from the class. Okay. It's not calling from this. Okay. What if I remove this too? What if I remove it from here? Let's remove this from class C. Compile class C. Compile this and entry point also compile. Let's run it again. Now it is calling test from demo A interface. Now it is going to the interface. Okay. So the JVM works like this. Okay, this is how the JVM works like. First of all, JVM will try to find test method over here. The moment you call test method, it will try to find it within itself. If it finds it, good, then this will be the one that is going to execute. But if there is no test method over here, then it will first look at the class, not the interface, the class which is getting inherited. There it will try to check, not the interface. First it will check it itself. If it cannot find it, it will go to the class, not the interface. It will find. If it finds, then this will run. But if this is not here, then it will go to interface. That's when it will find it and run it. Okay. So first it will search in its own class. If not, it will go to the parent class. If not, even if you like, only if you don't find it here, then it will go to the interface. Interface is the last option. Okay, then it will go here and it will see if the test method exists. If it exists, it will run. Now you might say, what about some other interface? Say some other interface that has this test. Well, you cannot have that. Why you cannot have that? Because you remember, if two interfaces have the same method name, it won't even allow you to implement this, right? So that case is anyway obsolete. Okay, it's not obsolete, it's discarded, right? Right. So yeah, that's all about classes and interfaces, abstract classes and interfaces. Congratulations, we are done with object oriented programming completely. Okay, we are done with the basics of object oriented programming. We are done with packages, inheritance, polymorphism, abstract classes and interfaces. We are done with everything. So now it's time to close the chapter completely for object oriented programming. See you in the next video. Bye bye.